Alright guys, today we're going to do section 4.7 inverse trig functions part 2. So yesterday or whenever in class we learned about the composition of trig functions and their inverses, and today we are going to do the same thing, but this time we are going to find the composition of trig functions and their inverses, but not necessarily the same trig function. So if you look at number 14, we are finding the sine of the inverse of tan, arctan. Excuse me. So the inverse of tan, what we are trying to do is find the angle of our triangle. So we are trying to find in the inside here the angle for which tan in a right triangle is 4/3, so opposite over adjacent. So let's recap. Tangent and sine both use quadrants 1 and 4 for the inverse. So Q1, Q4, and that is for inverse sine and inverse tangent. Cosine, on the other hand, uses quadrants 1 and quadrant 2 for inverse cosine. Sorry, my handwriting is terrible here. So when we are finding the inverse tan, we are going to draw our triangle in either quadrant 1 or quadrant 4. If it's positive, we're going to draw it in quadrant 1, and if it's negative, we'll draw it in quadrant 4. Same goes for inverse sine. So for number 14, we are going to draw a triangle in quadrant 1 because arctan is positive, so quadrant 1, and theta goes here, and tangent is opposite over adjacent. So what you are doing is you're saying, all right, the trig relationship of your angle. So 4/3, you are trying to find what the angle is that has the relationship of tangent opposite over adjacent. So this is a right triangle. So we are going to use the Pythagorean theorem to find the hypotenuse. If you notice quickly, this is a 3, 4, 5 triangle. If not, just use Pythagorean theorem. So now you just drew the triangle. This whole inside the parentheses is just setting you up to say, all right, we're looking for that angle that has that relationship, 4/3. And your last step you need to do is now, this is just this angle. Arctan of 4/3 is just telling you to solve for this angle. We don't need to know that exact angle measurement because now we're finding the sine of that angle. So we're just looking for the trig ratio of theta in this specific triangle. So the sine of theta is opposite over hypotenuse, so your final answer is 4/5. I find these ones to be a lot easier than doing the composition with the other angles. All right, number 15. Cosine of the arcsine of 24/25. Whenever you have a positive angle, you are just going to draw your triangle in quadrant 1. All right, that was pretty terrible. So sine, arcsine now, so 24, oh, that's not 24, that's 25. 24 over 25. Opposite over hypotenuse. Notice I'm going based off of the trig ratio of the inside here. Using the Pythagorean theorem, go ahead and solve for the adjacent side. And this is where theta is. So whatever 25 squared minus 24 squared is, is 49, so the square root of 49 is 7. All right, and now we are going to find the cosine of this angle. So this triangle, cosine is 7 over 25. So inside the parentheses, you're just setting up your triangle. Outside the parentheses, you are finding what that answer is. All right, number 16. Inverse tan of -3/5. Now it's negative, so that's where we need to go over to this unit circle over here. Tangent is negative. The inverse tan is negative in quadrant 4. So we are going to draw a triangle in quadrant 4 now. Tangent is opposite over adjacent. Here's 3, here's 5. And we need to pause for a minute and say, all right, where's the negative going? The negative's going with the y value here. using the Pythagorean theorem, the square root of -3 squared plus 5 squared. So 9 plus 25. Our hypotenuse is going to be 34. That's our triangle. Now let's find the secant. Well, that's nice because we don't need to rationalize our square root because secant is the reciprocal of cosine. So the secant of this angle is going to be the hypotenuse over the adjacent. So root 34 over 5. All right, last one we're going to do today. We have the inverse cosine of -2/3. Cosine is negative. Look at your unit circle up here. Cosine is negative in quadrant 2. So we have to draw our triangle in quadrant 2. 2/3. The hypotenuse is never negative, but our x value is negative, so the -2 goes there. We are looking for our y value, so using the Pythagorean theorem, 3 squared minus -2 squared, so 9 minus 4, take the square root. All right, so we get the square root of 5 as this one here. And then the sine of this is opposite over hypotenuse, so your final answer for this would be the square root of 5 over 3. That is it for this section. Let me know if you guys have any questions, and we will go through this again tomorrow. Have a great day. Thanks, guys.